All right. On this next one, it says describe the symmetry of each icon and then copy each shape. Well, the cool thing is you don't have to copy each shape. We're not going to do that. But we're going to draw any lines of symmetry. And if there's rotational symmetry, we're supposed to give the angle and the order of symmetry with this. Now, this is the yin and yang symbol. And that we see it's very common. If you look at it, there is no line symmetry. Like, I cannot divide it perfectly through the center of the circle in order to get that. But, so we have no line symmetry, so that's easy, no line symmetry. But does this have rotational symmetry? Now, I'm going to ignore the colors at this moment when we're working with this. So if I'm doing this correctly, literally it should, basically the only difference was that they changed the different colors of the symbols here. It does have rotational symmetry. I literally could rotate this and the black would take over this, but it'd be perfectly at the same location. So it would flip. So our rotational symmetry, rotational sim, I would say yes. It's going to be 100, the angle of rotation, no symmetry, is going to be 180 because I can only go 180 with that, which automatically makes it the order of 2. Now, why is it 180? Remember, I go halfway around in order to get that, so half of 360 is 180. Now, I'm looking at the next one. So here we have basically a square within a square. It's a pretty common diagram that's drawn out there. And I want to know how many lines of symmetry, or if it does have symmetry. And this one's real obviously, yeah, it does have symmetry. So it does have line symmetry. All right, how many does it have? Well, we should have at least 4, because I can go here, 1, make sure I draw my arrows to make a line. We should have our second one, 2. I have one here, 2, and then they have 3. That should be my 4th one here, excuse me. Should be 4. All right, so we have 1, 2, 3, 4 lines of symmetry, if you did it correct. Then we're supposed to ask how many, what's the rotational symmetry with this? Well, the cool thing is it's going to end up being 90 degrees because I have my 4 equal parts and it perfectly rotates around that. So does it have rotational symmetry? Oh yeah, it does. The angle of rotational symmetry, I don't know why I'm writing this all out. Oh well, it's the way I'm going today. It's going to be the 360 divided by 4, so that's 90 degrees. And so then what is going to be your order? Your order is going to be 4. Now on this next one, I want you to look carefully at it. This is not something, this is actually, I think, a fruit. Please understand, I got this off the internet. I just thought it was a really cool looking piece of symmetry with this. When I look at it, at first I'm thinking, obviously I can see rotational symmetry with this, but does this really have line symmetry? And the cool thing, it really does. It goes from the top here to like the lower spot every single time. So it's like the line symmetry going this way. And I can do that for every one of these. I can go smack dab in the middle. Oops, I'm going to go all the way around. Go all the way here. Sorry, that takes a little bit of time to get these. All right, so let's count these. I got 1, 2, 3, 4, 5, 6, 7 lines of symmetry. So does it have line symmetry? Oh yes. In fact, 7 lines of symmetry. Does it have rotational symmetry? Yes, it does. The cool thing about rotational symmetry on this one, we have 7 of these. So it's not even like this perfect little angle. So our angle of rotational symmetry is really just 360 divided by 7. And I'm just going to leave it as that for right now. And our order, because we can do this, rotate 7 times, would be 7 when we're working with it. So it's kind of a cool thing. All right, so that's working with the different ones of symmetry. So it's a little more complicated than what we did on Friday, but it gives you a little better understanding. But we actually have even 3-dimensional types of symmetry, which we're going to talk about next.